Good morning, everybody. Okay, that works. All right, we can save some time for everybody to have a sit. So before getting started, I would like to acknowledge my research team at Aphasia Women's University. And the talk that I'm going to be presenting today is the outcome from the interdisciplinary collaborations with the Department of Neurology and Department of Nuclear Medicine. Okay, so the concept of the mild cognitive impairment has been first introduced by Peterson and colleagues in 1990 as a concept of the transitional stage from normal aging to dementia. And since then, the concepts of and the definition of MCI have underwent the couple of revisions of the definitions. First, they just incorporated the components of the memory impairments. Later on, they also have been extended to the impairments in cognitive more than one domains of the cognitive impairments. And later on, the biological markers have been incorporated into the phenotyping, the classification of the subtypes of the MCI. Okay, so the core clinical characteristics of the MCI include objective cognitive impairment in one or more cognitive domains that makes them different from the subjective cognitive impairments. And people with MCI have to maintain, preserve independence in functional abilities as confirmed by the assessments through ADL and IADL, and that makes them different from dementia. So there are a couple of subtypes of MCI. First, depending on the presence of the memory impairments, they can be categorized either amnestic versus a non-amnestic type of MCI. And second, depending on whether one or multiple domains are involved, they can be categorized as a single domain versus multiple domain of MCI, leading to the four subtypes of MCI: amnestic single domain, amnestic multiple, and non-amnestic single versus non-amnestic multiple domain. And more recently, additional layers have been introduced, incorporating biomarkers of the AD pathology, such as amyloid beta, to further refine the classifications. So let me switch the gear a little bit toward the linguistic marker of the MCI. Our group published a paper in 2020 in JSHR, which suggested that the syntactic complexity may serve as a linguistic marker to differentiate MCI from normal aging. And in this paper, we employed two different syntactic structures, such as active and passive sentences. And everybody in this room would agree that passive sentences are more difficult than the active sentences in many ways. But I'm not going to talk about much of the details why this talk. And from this paper, we found that individuals with MCI performed significantly worse in the passive forms than compared to their controls. However, the two groups were not significantly different in the active sentences. And among many different types of the logistic models, the model including only passive forms significantly differentiated the two groups with the ROC value of 0.78. So which was promising to us, and that made us to think about the link between the linguistic marker and biomarkers for MCI, asking a question whether a linguistic marker differentiates MCI group with amyloid beta burden from those without it. So here are the specific research questions that we addressed in the study. The first research question is there are significant group differences between amyloid beta negative and positive group as a function of syntactic complexity. And the second question is, which sentence type serves as the strongest predictor of the group classification? And finally, we examined which model best distinguishes between the two groups when the linguistic markers are combined with the cognitive subdomain measures. So we recruited a total of 85 participants with the MCI, but based on the exclusion criteria, we ended up with 67 amnestic MCI participants. 30 was categorized as amyloid beta positive and 37 amyloid beta negative group. And we're going to talk about the amyloid beta PET scan later. And all of them were CDR 4.5. And these are the demographic features. And the two groups were a match for the age and education in IADL and depression score. However, positive amyloid beta groups performed worse on the Korean version of MMSE than the negative group. So all of the participants completed a comprehensive neuropsych test, which is standardized in Korean, including a variety of the cognitive domains such as attention, language functions, and visual spatial functions, memory, and frontal functions. So this is the quick summary of the neuropsych battery from the Seoul SNSB. So just try to pay attention to the blue lines that are highlighted, and those are the three subtests that elicited significant group differences between amyloid beta positive and negative. One under the visual spatial domain, rate complex video recognition test, and also whole overrunning recognition test under the memory domain, and for the fluency animal category under the executive function domain are the ones that elicited significant group differences. And try to remember that there are total of the four significant measures that elicited group depth differences from the neuropsych test, including MMSE and 3 of these, because those four variables will be used for the logistic regression model. So this is but as you can see, under the language domain, only the Korean version of the BNT is included. As we all know, the BNT is just lexicosemantic domain of the language functions, and the neuropsych test, although it's very comprehensive, it takes 2 hours to complete, but it doesn't have any syntactic features at all. So we are the minister sentence comprehension test, and I'm not going to go into much detail about the Korean syntax here. And we learned from yesterday, some of us are scared of the sentences. But I'm a big fan of the sentences. So we included total of the 6 sentence types, and for the sentence type, we had active sentences with 2 place verbs and 3 place verbs and passive sentences. And Korean syntax is relatively word order-wise, it's relatively free, meaning that we can scramble the argument structures, which allows us to have canonical and non-canonical features of each syntactic type, which makes very interesting to English speakers because passive sentences for English speakers are always the non-canonical, but for Korean cases, we can have non-canonical word order. The passive sentences having by phrase can come at the beginning of the sentences, and by phrase and empty can be scrambled. If you believe or not, that's the Korean. So for the PET, FBB was used as a PET tracer, and we used the brain amyloid plaque load BAPL. Was used as a visual inspection, so performed by the neuroradiologist. And we used the BAPS score consisting of the 3 levels, and level 1 is low amyloid beta load, and level 2 is minor, and level 3 is significant amyloid beta load. And among our participants, we identified that there are only 4 participants with BAPL level 2, so we excluded them. And with having 37 amyloid beta negative and 30 with amyloid beta positive. So for the statistical analysis, first we compare the group differences using generalized linear mix model, and we performed the discriminant analysis, and finally we ran multiple regression analysis to identify the linguistic cognitive model to predict amyloid beta status. Okay, these are the results. So we found significant type effect indicating that active sentences with two place verbs were easier to process as we all expected compared to active sentences with three place verbs and passive sentences. And we also had the word root effects, and interestingly enough, then we had group by type interaction, and the source of the interaction seems to be the case that the amyloid beta negative or the positive groups performed worse than the amyloid beta negative groups. That's the driving source for the interactions. And we also have the type by word order interactions, which was driven by the significant differences between the active two place and passives depending on the canonicity. So that's the simple example of the past and two individuals. And going back to the discriminant analysis, we put three types of the sentences into the discriminant analysis because we didn't include the word order type in this case because the word order didn't interact with the group, so we left it out in the discriminant functions. And we put the amyloid beta group as a dependent variable. From this analysis, we identified the passive accuracy, distinguish the amyloid beta positive from the negative groups, consistently with the general meanings. So then that makes us to think about computing the passive impairment scores measures. We just computed the scores from the passive sentences, subtracting from the average of the active sentences across the two place and three place verbs. And those what we call passive impairment index or the scores, and those are the individual scores across the groups. And we put these passive impairment scores as a base predictor, and remember the four different measures from the neuropsych test as the candidate predictors in the multiple regression, logistic regression model to identify whether there are significant models that differentiate this amyloid beta status. And we ran all possible combinations of the candidate variables leading to the 15 total models. And as you can see, the best fit model with the least AIC value and the highest value of the AUC is the model 1, which included passive impairment score and verbal fluency, animal verbal fluency, and rate figure complex recognition test. And those three combinations of the test elicited AUC 0.8458. So to summarize the results, we can say that MCI participants with amyloid positive biomarkers showed greater impairments in passive sentences than the other simpler types of the sentences, and more complex syntactic structures such as passive sentences effectively discriminate between amyloid beta positive and negative groups, and moreover, when the passive sentence scores index was combined with multiple cognitive domains such as rate figure, visual spatial domain, and verbal fluency domains, the model's ability to predict amyloid beta biomarker status reached up to 86% accuracy. So what's next? So our next plan is to conduct the SUVR analysis focusing on the ROI to see whether how specific regions of the interest relate to linguistic performance, particularly in terms of the complexity. And also, we are also planning to run the longitudinal follow-up study to track changes in amyloid beta burden and syntactic processing over time. This will help us to determine whether linguistic markers such as passive structures can serve as a sensitive indicator of disease progression in MCI. So I'd like to thank all of my students who have been always supportive and dedicated to our field, and as well as participants with MCI that made this study possible. Thank you for listening.
Okay, so we have 5 minutes for questions now.
I have a stupid question. Can you put the last line graph that you showed up? I must have missed something. The line graph, so that shows the construct there. Oh, okay. So, really interesting data, by the way, beautifully done study. I'm a little surprised that recognition is coming out instead of recall.
Yeah.
So I'm not sure what's going on there, but it could be because you're comparing two groups of MCI rather than comparing positive MCI to patterns of recovery controls. That's something to think about. And then semantic fluency is not surprising. Put it in with the language rather than with the executive, that doesn't work.
Yeah.
So the accuracy is out of how many? And what's in the middle there? Because I'm wondering why everybody's doing worse on that one relative to the first one.
Yeah, that's very interesting catch, because we were exactly wondering about why, and we are still figuring out. It's not the end of the story, but so the total scores is 36, and this is divided by the sentence type, meaning that 12 for each sentence type and 6 for each of the canonical and canonical types. So that in this case, the y-axis is going to be up to the 12. And as you can just mention, you just mentioned a very good catch. I think that the active sentences with 3 place verbs are lower in both groups, and we are still struggling, like why? Maybe two places with the 3 phrases and active sentences with the 3 place verbs. That's 1 through 5 phrases. So, but like a passive sentence is only 3 phrases. So in terms of the length versus the complexity, that's one of the components that has to be disentangled, and that's the feature that we should be into.
And it's really cool because the thing that's the hardest is not the thing that's most diagnostic.
Exactly. Yeah. Thank you.
Many thanks for your talk. So I'm curious about your passive, the faculty effects with the passives, and I wonder what is driving this effect. Is it movement? Is it the fact that there's a sentence with a verb? Is it the fact that the verb is inflected? What is it?
Yeah, thank you for that. Yeah, because I intentionally didn't talk about that much about the mechanism of the passivizations in Korean. So basically it's almost very same. Like noun phrase is moved to the upfront, and like a theme is phrased, placed in the place of the object, and the by phrase with the agent thematic role is formulated as by phrase in Korean, and the verb is going to be inflected with a passive morphemes. So that's the basic structures, but the different thing is between the Korean and English is just by phrase, and the M key can be moved around.
So you think movement is driving the effect?
Yeah, movement, or the thematic role changes, and many meanings are involved. Yeah.
Thanks, Dee. This was lovely. So, just a thought, picking up on Tamar's line of questioning about this, a suggestion about why the 3-place active might be so hard. Because Korean is an SOV word order language, there are a greater number of integration operations when you get to the verb. So that might explain why that is the case. Whereas for both the active and the passive, you have the same number of verb integrations when you get verb finality. Why no canonicity effect? And what does that tell us?
Yes, that's a very interesting question, and we still, because yesterday we plotted all the individual data just to make sure everybody follows the pattern, because it means it can be derived by certain groups of the subgroups of the group. So we just try to identify where this mean comes from, and looking at this individual data, I was shocked. And then I have to make another story, or you have to think through about Yeah, you are familiar with the working memory theory, like length versus computation resources of the working memory. So 2-place versus 3-place is maybe related to the span-related buffer compared to the active and passive is more involved in computational resources because the equation of the span is actually matched between active and passive. So, but looking at this dissociation here, I know that beta, negative group, they just perform worse in the length-related 3-place verbs. However, I know that positive group, they just perform worse in the computational resources demanding passive verbs. You know, like, I don't know whether it's double dissociation pattern going on or we cannot say just right now, but we have to dig into why. Maybe this working memory related dissociation.
I'll be interested to hear more as it develops. Thank you.
Yep, thank you.